welcome back to the channel. So we're going to be doing another video on our installment of the weapons components that we've been talking about. So we've done the gun and we've done a portion of the optics. The next thing that we're going to talk about is a little bit more conceptual based, and it's going to be also about optics. So right now we're going to go into optics part 2. All right, so in this video what we're going to talk about is MILs versus MOA. All right, the reason why is because those are the two angular units of measure that are used for optics. And then we're also going to be talking about reticle selection and how we can use reticles to our advantage to shoot, targets out to farther ranges with our optics, and how to employ our optics in the best possible way. All right, so MILs and MOA. MILs and MOA are two angular units of measure that are used in optics. All right, so when we think about optics, everything is working in a circle essentially. And what we're taking is from the center. If we imagine the shooter is in the center, our field of view is a sector of a circle. So as things are closer to us, that sector is smaller. As things are farther away from us, that sector is larger. And that's pretty apparent. All right, so those angular units of measure, we can actually use those in a specific way to find out things such as target range, or use it as an actual ruler in front of our eye, that's sitting right in front of our eye, to measure where our impacts are so that we can make second round engagements if we didn't hit the target the first time. All right, so there are two angular units of measure that are typically used in long range shooting. One is MILs, or MRADs, which is short for milliradians, and then we also have MOA. All right. As I talked about earlier, I'm partial to using MILs. All right, and we're going to get into why in just a second. So first, I'm going to explain MOA so that I can explain to you exactly why MOA is just a bunch of bullshit. So the whole minute of angle system is based off of the same way that our timing system works. So everybody knows that there are 60 minutes in an hour, and there are 60 seconds within a minute. And the only reason why there are 60 seconds in a minute and 60 minutes in an hour is based off of arbitrary numbers that date all the way back to like ancient Mesopotamian times. The ancient Sumerians and the Babylonians just liked the idea of using the number 6. So they broke up the day, or the day, into 24 hours because 6 goes into 24 easily, and they broke up those hours into 60-minute increments, and then so on and so forth. So it all goes back to keeping track of time, all right? And we use minutes of angle in conjunction with degrees, all right? So everybody understands that in a circle, there are 360 degrees, right? And over here we would have 90, 180, excuse me, and 270, all right? 360 degrees within a circle, and then each one of those degrees, so if we break that up, we have all of our degrees. Each one of those degrees is broken down into 60 minutes, just like there are 60 minutes within an hour. And then you can further break down each one of those minutes into 60 seconds of angle, all right? So from large to small, we have 360 degrees in a circle, 60 minutes of angle within each degree, and then 60 seconds of angle within each minute of angle. All right, again, the only reason why this unit of measure exists, broken down into these arbitrary numbers of 60, is based off of the same reason why we use 60 minutes to the hour in time. It's all arbitrary bullshit that's just stood the test of time for thousands of years. It doesn't actually have any mathematical or scientific meaning behind it. It just is what it is because that's what it is, all right? So now if I erase this and I redraw my circle, we're going to talk about MILs or MRADs or milliradians. So it's officially milliradians. All right, and the reason why is when we talk about circles mathematically, we're most of the time using trigonometry or trigonometric functions, and within trigonometric functions we use radians as a unit of measure. All right, so everybody understands that from the center of a circle to the edge is known as the radius, right? Now if we were to take that length and place it across the actual edge or the circumference, and then bring that length back to center, we would have what's known as a radian. All right, a radian. And everybody who graduated the 5th grade should know that the measurement or the formula for a circumference of a circle is 2 pi r, right? So we know that the r is the radius, and the length of the radius along the circumference is, and then coming back, creates a sector that's known as the radian, right? So that means there are 2 pi radians in a circle. And that's all based off of the mathematical constant pi, which is 3.14 approximately. Right? So this is actually rooted in science and fact. So if we do 2 pi r, and this is simply, for arbitrary reasons, r equals 1, that'll tell you that 3.14 times 2 means that within a circle, there are 6.28 radians. All right. Now, if we were to break these radians down further, because as you can tell, a radian is much, much larger than a degree. There are 360 degrees in a circle. There are only 6.28 radians in a circle. But we take those radians, we break them down into increments of 1,000. All right? Increments of 1,000. And that's what gives us our milliradians. Milli being the prefix for 1,000, and then radians being the actual unit of measure. All right, and then what we do is we further break those down into tenths of the 1,000 radians. So tenths of a radian, tenths of a milliradian, excuse me. So the reason why this makes, to me, a lot more sense is it's actually rooted in something that is based off of mathematical and scientific fact. The radian is the length of the radius measured along the circumference of the circle to create a sector, all right? And that's rooted within the mathematical constant pi. And the mathematical constant pi is something that people have spent hundreds and hundreds of years refining down to what we know it as now, okay? Now, both of these units of measure have pros and cons, okay? Okay, now both of these units of measures have pros and cons. Really, MOA, the only pro that it has is it transfers pretty closely to the inch, right? So a lot of people will talk about minutes of angle equals an inch, all right, about an inch. That's not necessarily true. TMOA or true MOA is equal to 1.047 inches, okay? But MOA translates fairly well to inches. So when people are shooting, they'll shoot, to zero their gun. Their group may be 3 inches left from center. So they'll go, okay, my group's 3 inches left from center. I need to adjust 3 MOA right. But we'll talk about using a reticle in a second. There's no reason to ever worry about this, right? Because this conversion is not necessary. If you have a reticle in front of your eyeball and you can see the shot group through your scope, you can simply take those subtensions of the reticle and use that like a ruler to adjust without ever measuring or converting anything, right? So we can always just measure in MOA or MILs. We don't need to measure in MOA, then convert to inches, then convert back to MOA and adjust our scope, right? So this is a pro in a way, but it's not ever going to be necessary if we know how to use our optic and reticle appropriately. All right, when it comes to converting MILs, MOA converts well to inches. MILs converts well to pretty much every unit of measure. Because MILs are broken down into thousandths and they're rooted in scientific and mathematical fact based off the constant pi, if I have 1 mil or milliradian, that can be equal to a number of different things. It could be equal to 1 inch at 1,000 inches, which is a weird unit of measure that we're not normally going to use, right? It could be equal to 1 yard. We use yards a lot in long range shooting. At 1,000 yards. So if you're shooting at 1,000 yards and you're a mil off, that means you're 1 yard off. If we're at 100 yards and we're 1 mil off, then we're 1/100th of a mil off, all right? Which is 3.6 inches. Now, another unit of measure, 1 meter, 1 mil is equal to 1 meter at 1,000 meters. So MOA only converts well to inches. MILs convert well to every single unit of measure because it's just a 1,000th of the distance that you're shooting at. However, as we get more into our field crafts, you'll understand why this is an important concept, because you can utilize this mathematical fact to actually convert mil readings within your scope using very, very simple algebraic expressions to understand how far away your target is, as long as you understand your target size. Okay, so this concept is extremely important, and MILs beats out MOA every single day of the week on this one when it comes to easy conversions. All right. So one pro for MOA that MOA definitely has on MILs is MOA is usually broken down into smaller subtensions. So if you're shooting extreme long range, it may be better to have an MOA scope because you can have one MOA scope or an MOA scope that's broken down into eighths of an MOA, right? But typically what you're gonna find is scopes that are in a quarter MOA, and you may even find some scopes that are in a half an MOA. And those are increments of adjusting on your actual turrets. Whereas with MILs, you're almost always gonna have 1/10 of a mil. All right, so every 1 mil, you'll have 10 clicks. All right, whereas every MOA scope, you may have 8 clicks per MOA or 4 clicks per MOA, all right? And the reason why this may give you more of a fine adjustment is because 1 mil is equal to 3.43 MOA. All right, so about 3.5. So you can fit 3.5 MOA into a mil. So if you can have 1/8 of an MOA adjustments, that means that you have about 25-ish, don't quote me on it, I'm not good at arithmetic on the fly, 25-ish clicks to 10 clicks per mil. All right. However, for most shooters, especially shooters that are doing competition and shooters that are in a tactical scenario, you're never going to need that much adjustment on your scope. As a matter of fact, this much adjustment on your scope is actually going to hinder you because it's going to be extremely annoying if you have to adjust your scope in between targets. Whereas 10 clicks is a perfect number when it comes to that. Also, the disadvantage, just like I just said, the amount of clicks, the disadvantage of having all of those and MOA being a larger or more MOA fitting into one mil, the disadvantage of that is if you're trying to memorize your elevation settings, you have to memorize huge numbers when it comes to MOA. So, for example, your average target at 300 yards, which is so close that you could pretty much throw a rock at it, for 308 is going to be 1.2 mils, right? Whereas if we were to convert that over to MOA, that's going to be more like more like 4 MOA, right? And then as we go farther and farther out, so that's for 300 yards. If we go to 500 yards, where we would normally have something like 3.1 mils, convert that to MOA, you're gonna have over 10 MOA that you're gonna have to worry about. And we're not even, we've just barely broken the 500 yard threshold. So before you ever get to 10 mils, you might be out to 800 yards or even farther, depending on what caliber you're shooting, for memorizing your actual elevation settings or having to write those down. Whereas we're barely past 500 yards and we're already past that 10 mil mark into the double digits. All right, and a lot of people, when it comes to math, hate fractions. All right, MOA works in fractions. Whereas mils works in decimals or tenths, which is a lot easier to work with, especially on the fly. So I can remember my dope for 500 as 3.1 mils. All right, which is a lot easier to remember than 10 and 1/4 MOA. All right. If you are an MOA shooter for some reason, and I haven't convinced you that mils are more rooted in fact and science and are better, an easy way to do it is remembering your dope or your elevation setting in dollars and cents. All right. So mils, it's as easy as 3.1, 3.2, 5.5, whatever. For mils or for MOA, you can remember your dope as 15.5, or 15.25 dollars and cents. All right, 15.75. All right, next we're going to talk a little bit about reticles and the better options for reticles in your scope and why you'd want to use them. All right, like I talked about earlier with mils and MOA, in my opinion, mils are just better. There are more applications for mils. They're easier to remember. They're easier to use. They're rooted in scientific fact. All right, MOA is arbitrary. The only thing that it's got is it's got finer units of adjustment, which are really only usable for extreme long range. Where as that angle grows, that sector becomes larger and larger. All right. So there are a couple different reticles. I'm going to talk about the history of reticles just a little bit. And then we're going to talk about pretty much the reticle that you're going to be looking for in your scope and why you'd want that. All right, and I'm not going to draw anything on the board. I'm just going to digitally insert it later during editing. So I'm just going to be pointing at the board like a crazy person. However, you'll think that something's just going to appear there. All right, so back in the day, there was pretty much just the duplex reticle, which is the simple hunting reticle that you would find in like your cheap Tasco scope from Walmart. All right, this is not something that any precision shooter is going to want to use. You could use it if you really wanted to, if you knew how to use it, but most of the times these are in a second focal plane scope anyway, so you're probably just going to lose your 0 every time you zoom in. All right, so moving on from that. Next is pretty much the reticle that most people think of when they think of a scope, which is your Gen 2 mil-dot duplex reticle. All right, this is the classic sniper reticle. This is a reticle that I was trained on and that I had used for almost 10 years until we got reticles that are more modern. All right, so on the mil-dot duplex reticle, you've got a center crosshair, then some subtensions at every half mil increment, and then mil dots, which can be used as aim points for aiming if you're going to hold on target versus if you're going to dial your dope. And we'll talk about that in a second with employment. All right. However, even though this is a good reticle, one of the biggest issues with this reticle is all you really have is that crosshair to use. So if I want to hold on, off the target instead of dialing my elevation wind, at some point I'm going to be holding in that empty space on the left or the right side of the vertical stadia line. Because there's just not enough stuff going on for me to use. There aren't any subtensions. So if I need to hold 3 mils onto the target, but then a mil of wind left, now I'm gonna have to kind of play the guessing game a little bit as to where I'm actually putting my reticle in relation to the target. All right, so what we've kind of moved on to nowadays, which is the kind of reticle that anybody should have within their scope, is a Christmas tree reticle or a Horus reticle, originally designed by Accuracy First, with the most famous line going on was the H59 or the Horus 59, and now they have their Tremor series, the Christmas tree reticle. So this reticle has a horizontal stadia which has a ton of data on it, which can be anywhere from just simple mil increments, and instead of dots it uses hashes, to mover brackets depending on which one you get. If you get the Tremor 3 like I have posted here, then that reticle can help you shoot moving targets. Now these reticles seem a little bit busy, and there's a spectrum of the really busy tactical ones like the Tremor 3 that I have here, or the more streamlined sports shooting reticles where all you really need is something to hold on to. But the brilliant thing about these reticles is you have this Christmas tree that comes down that allows you to, as you hold elevation on the target, still have an aim point for relative wind. All right, so you can either do that after, we're going to get into calling wind later in this series, but you can either have a mil reading for your wind hold, or if you do have the Horus reticle or the Horus Tremor 3 reticle like is pictured here, this has wind dots in it, which when you get your gun number, which we're going to talk about when we get to ballistic calculators, you can use to calibrate those wind dots. So if you have a specific wind bracket, each one of those wind dots becomes a specific wind value. So when it comes to reticles, this is definitely the type of reticle you're going to want. And most companies offer their version of that reticle, and then also a lot of them offer the Accuracy First reticle series as well. So when you're purchasing a scope, this is the kind of reticle that you're going to want. All right, so the last thing that we're going to talk about in this little optics portion of this series is the actual employment of your optic. All right, so we talked a lot about the nomenclature of the actual optic in the last video. We're talking a lot about conceptual based stuff in this video. So now how do I actually use this optic to engage a target at distance, right? So we have to use the optic like I described in that last video to take advantage of the trajectory of the bullet, right? And what we're using are those angular units of measure that I just talked about earlier. And there are two ways that we can employ this optic in that capacity, right? So like I talked about earlier, or in the last video, we're just going to recap. Let's say my target is at 500 yards. We're going to use that 500 yards again. Let's say that target is at 500 yards. All right. However, we ranged it you know, we got that the target's 500. Someone gave us the range, we ranged it with the laser rangefinder, it doesn't really matter. All right, target's at 500 yards. We use our ballistic software, which I'm going to teach you guys how to use in the upcoming videos, to determine that for this gun to hit the target, I need to use an elevation setting of 3.1 mils, right? So there are two different ways that I can apply my 3.1 mils to this gun so that I am shooting the target, all right? I can either use my actual turret and click until I get to 3.1. At that point, what's happened is my reticle, by pulling up, has moved down, which will change the angle in which I'm going to view the target. So that will move my reticle down, which will force me to move my gun up to see that target, which will increase the angle of attack of my actual bullet, allowing it to reach the target at a farther distance, right? Now, let's say that I want to engage a target extremely rapidly. I don't need to dial and move my reticle at all if I don't want to. What I can do is actually just hold the 3 mil line of my reticle on the target, right? Because we need 3.1 mils. That's pretty close to 3. So what I'll do is I'll just hold the 3 mil line on the center of the target or a little bit higher, right? And when I talk about holding, imagine this is a reticle, or my reticle, and I have my 1 mil line, 2 mil line, which is usually going to be marked, 3 mil line, 4 mil line in that Christmas tree style as I was talking about. What I can do now is, as opposed to dialing, I can simply take this 3 mil line and place it on my target. Now I'm essentially doing the same exact thing as when I clicked 3.1 mils up, but instead I'm just using that reticle to my advantage by simply just aiming higher on the target. If I clicked my reticle down and then used this as my aim point, the center crosshair, it's the same thing as if I left my reticle center and then aimed higher, right? So that's what we mean by holding, and there are advantages and disadvantages to dialing and holding. One advantage to dialing is you have an easier, more identifiable and refined aim point, right? And then you can quarter the target, like we're going to talk a little bit about in our fundamentals of marksmanship class. However, holding is really, really good for rapid target engagement. If I have targets at several different distances and I don't have time to dial on my scope, then it'd be really beneficial for me to potentially hold. All right, and then like I was talking about before, I have this 3 mil line here. If I need to hold some wind too, I can hold a little bit left for a left to right wind, and then instead of just holding at the center, I can hold that, whatever that wind reading is. All right, so that's basically how you would employ your scope. And now we've kind of moved on from optics. That's it. That's pretty much everything you need to know about the optics to get started. We may go a little bit more in depth into how everything works later, but that's pretty much all you need to know. So without further ado, I really appreciate you guys tuning in, and I hope you guys stay Apex.